Welcome to my channel Tech and Chill. Today, we're going to demystify a really powerful AI concept. It's all about how you can teach a large language model to become an expert on your private data. We're talking about Retrieval-Augmented Generation, or as everyone calls it, RAG.
Here's what we're going to cover. First, we'll set the scene with something I call the 500 gigabyte challenge. Then we'll see how RAG swoops in with a super smart solution. After that, we'll get into the nitty-gritty of how it all works step by step. We'll even walk through building a basic one. And finally, we'll talk about the secret sauce that makes a RAG system truly great.
All right, let's kick things off with our first section, the 500 gigabyte challenge. To really get why RAG is such a game changer, you first have to appreciate the massive problem it's designed to solve. So imagine this. Your mission is to make an AI an expert on a literal mountain of your company's private info. Let's just put a number on it. Say your company has 500 gigabytes of internal documents. That's everything. Product specs, old meeting notes, HR policies, the whole shebang. And you want an AI assistant that knows it all, inside and out. The problem is, you can't just drag and drop 500 gigs into a chatbot. It just doesn't work that way. So, where do you even start?
Well, a couple of ideas might pop into your head right away. Idea one, just search everything. But can you imagine? Every time someone asks a question, the AI has to scan all 500 gigabytes? That would be painfully, unbelievably slow. Okay, so what about idea two? Let's just pre-summarize everything. The problem there is you're making a huge gamble. You might be throwing away a critical detail before anyone even thinks to ask about it, which means you'll get inaccurate answers. So clearly, neither of these is going to cut it. We need a much smarter way to do this.
And that smarter approach, you guessed it, is RAG. This is our second section, and it's all about the solution. It's so clever because it really does give you the best of both worlds. You get the deep knowledge of a full search, but with the speed and efficiency of only looking at what's relevant.
See, the big idea with RAG is to change how we think about documents. We stop treating them like just a bunch of text. Instead, we transform them into a kind of specialized, searchable memory for the AI. How? By turning the meaning of the words and sentences into numbers. We call them embeddings. This lets the computer understand and compare concepts and ideas, not just simple keywords. It's a huge leap. So let's put a formal definition on it. Retrieval-Augmented Generation is a method that lets an AI retrieve relevant, up-to-the-minute info from a private knowledge base before it generates an answer. This is massive because it means the AI is no longer stuck with just its old training data. It can learn new things, your things, on the fly.
So that leads us right into our third section. How does this thing actually work under the hood? It might sound pretty complex, but honestly, the whole process breaks down into a really simple and elegant three-step flow.
Think of it like a little dance. It starts with retrieval, which is just a fancy word for finding the right information. Then comes augmentation, where we cleverly add that information to the AI's prompt, and it all ends with generation, where the AI uses all this great new context to come up with a really solid answer. Retrieve, augment, generate. That's it.
Let's zoom in on that first step, retrieval. So when you ask a question, the first thing the system does is turn your question into one of those numerical embeddings we talked about. Then it performs what's called a semantic search, and this is the absolute key. It's not looking for keywords like a search engine from the 90s. It's looking for chunks of text from your documents that have a similar meaning, a similar vibe to what you're asking.
Okay, next up is augmentation, and this is where the real magic happens. All that relevant info we just found gets automatically stuffed into the prompt right alongside your original question. It's like giving the AI a little cheat sheet just for that one question. This gives it the exact context it needs to be accurate, and the best part? You don't have to do any expensive, time-consuming retraining of the model.
And that brings us to the grand finale, generation. The large language model now has everything it needs. It has your original question, and it has this rich, new context that we just handed it on a silver platter. Now it can use its incredible reasoning skills to put it all together and give you a detailed, accurate answer that's actually grounded in your own documents.
So, that's the theory. It's pretty cool, right? But now, for section 4, let's make it real. Let's walk through the basic steps of how you would actually build your very first RAG system.
The very first thing you need is a place to store all this knowledge that we've converted from your documents. I like to think of this as setting up the AI's brain storage.
For this job, you'll use a special tool called a vector database. A popular one is ChromaDB. Inside it, you create something called a collection, And that's basically the folder where all the numerical versions of your documents are going to live, all ready to be searched based on their meaning.
Okay, storage is ready. The next step is to actually process our documents. This is a two-part process. First, we break them down into smaller, manageable pieces, and then we convert those pieces into the numerical vectors we've been talking about, the embeddings.
Now, a really common strategy here is to break your text into, say, 500-character chunks, but you also add a little overlap between them, maybe 100 characters. Why? That little overlap is crucial for making sure you don't accidentally cut a sentence or an idea in half so you preserve the context. Then you use a special embedding model to do the hard work of turning each of those text chunks into its own unique vector.
All right, our AI's brain is loaded up and organized. Now for the fun part. It's time to actually ask it a question and see that semantic search do its thing.
So, a user asks a simple question, like what's the pet policy? That question immediately gets turned into an embedding. The system then zips through the entire database, comparing that question's embedding to all the document embeddings it has stored. And just like that, it pulls out the top few chunks that are the most similar in meaning, the ones that are actually about the pet policy, even if they don't use those exact words.
So, now we've got a basic system up and running. But for our last section, let's talk about what takes it from just okay to great. Because with RAG, the difference really is all in the details. Learning how to fine-tune the system is absolutely key.
And this table right here shows one of the most important details. Your chunking strategy has to match your data. It's not one size fits all. Look at this. For legal documents, you want bigger chunks to keep those long, structured paragraphs intact. But for something like a customer service chat log, you want small, sentence-level chunks with lots of overlap to keep the back-and-forth flow of the conversation. It makes total sense when you think about it.
So, the main takeaway here is that you have several different dials you can turn to get things just right. Getting your chunking size and overlap correct is critical for accuracy. The embedding model you pick can also have a big impact on performance. And finally, your retrieval strategy, things like setting a similarity score so you only get highly relevant results, that helps filter out the noise and stops the AI from getting confused. So there you have it. We went from a huge, seemingly impossible data problem to a working RAG system that can give you fast, accurate answers straight from your own private documents. It's an incredibly powerful technique. And that leaves us with one final thought. Now that AI can be given this kind of specific, expert knowledge, what's the very first problem you would want to solve with it?